Now let's take a second to think through some word problem things here. Instead of trying to overcomplicate some stuff, let's just think through what makes sense. Here it says a low energy swing door uses a spring to close the door and a hydraulic mechanism to dampen or slow down the door's movement. If the door is open at an angle of pi over 4 and then released from this resting position, the angle theta of the door t seconds after it was released is given by this function. Now I know this function looks terrifying, it looks ridiculous. Of course we could graph it and make some sense of it. But as the time gets further and further away from when it was released, if it exists, we'll find that limit. Well, think about that. If you've ever released a door that has a spring on it, you release it, and it might come back, and it's slow. Oh, here's our door, released it, boom, and then it's eventually going to be at an angle of 0, because that's what our outputs are. The angle it is right there at the door frame. It's going to bounce, 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 bounce. It's eventually going to finish at 0. That's what we'd expect, right? I mean, this could be a janky old door that doesn't shut all the way, but what would you expect? You'd expect that angle to get closer and closer to 0, and I thought I had the graph up here. So, all right, so I'm going to come in here. Of course, I could zoom in on that, but notice as x gets larger, as it gets closer to infinity, we can clearly see it is approaching 0 right there. Look, clearly see it's approaching 0, and that does validate what we would expect. It was not approaching anything but that x-axis right there at 0. Let's think about this next one here. It says the concentration of milligrams per millimeter of a certain medicine in a patient's bloodstream T hours after the medicine has been administered is given by C of T equals A times T times E raised to the power of negative 0.18 T, where A is a positive constant. Estimate the limit as T approaches positive infinity for C of T if it exists, and interpret our results. So once again, we have a function, and A is some positive constant. We don't exactly need to even know what A is. Think about A is just the starting amount. So A could be 2 milligrams. A could be 67 milligrams. Whatever it is. I mean, just think about that. If you ingest some substance, it's not going to be in your bloodstream forever. It's not. We've all heard, we've all watched the news or whatever. We've watched some TV show where they say, hey, I did drugs, and I'm wondering, am I going to pass that drug test? Well, it takes time, and as time goes on, it leaves your bloodstream. Whatever. Don't want to bring drugs into this, but that's what we're just talking about medicine, and that's what medicine is. So if we graph this and we just get a better understanding of it, now we could think about our e to the power of x, and we can try to figure out what this is going to look like. I'm just going to let a be 1 as I graph this. I'm actually putting in x's right there, and if I graph this, I need to zoom out, apparently.
There. Ooh, what is it approaching? Looks like it's approaching something. No, it's not that one. That's not that. Looking like it's approaching 0. Looking like it's approaching 0. Let's see, one more time.
Should be enough evidence. Yeah, it's definitely approaching 0. As time moves on, that medicine is leaving the bloodstream. It's getting closer and closer to 0 of it being in the body at all. All right, so just thinking about this in these practical situations, yes, we can evaluate the limit. We can look a little bit more at it. We will be able to deal with that more and more as we look at it. But going to infinity, think about the end behavior of these graphs. Look at the graph if you need to plot it with points, or if you need to graph it in your calculator, you need to think about the transformations on it. Don't get overwhelmed by the fact that it's a word problem.